All right, so since this is still based on working with the quadrilaterals, like the things you guys are going to prove are going to be, hey, here's some coordinates for a quadrilateral. They'll give you the 4 vertices. And they might ask you to say, show that this thing's a parallelogram. Or it might just be like a general, name the most specific name for the quadrilateral. That kind of stuff. So what I'm going to give you here is going to be things to check whether or not, like to see if things are a parallelogram or a rhombus. Those are the ones we're going to be mostly concerned with. All the other ones, like if you have a kite, like if you have something you have to show a kite, it's mostly go right to the definition of a kite, where you need 2 sides right next to each other being congruent, but not all 4 sides being congruent. But because these have other ways to go about showing that they're a specific shape, like a parallelogram, I've got 3 things here. And I'm also going to tell you what kind of to use when you go about showing things. Like this case, it's the parallel sides. When you show things are parallel, if they give you coordinates, just do the slope. Because remember, if you got 2 lines that are parallel, the slopes have to be the same. Okay? And guys, if you forgot, right, your slope formula is the y2 minus y1 over x2 minus x1 with the coordinates that they have. So you subtract your y coordinates, put it on top, subtract the x coordinates, put it on the bottom. All right? Then the other way to do this is going to be, you want to show the opposite sides are congruent to each other, but not necessarily all 4 of them being equal. So in this case, you would have to use distance formula, which if you remember, distance formula is just Pythagorean theorem, so you can do it with Pythagorean theorem. Or you can do it as squared. Or you can use the actual distance formula, okay, which is the difference in your x coordinates squared and the difference in your y coordinates squared added together, right? Because remember, that's essentially your a squared plus b squared part of Pythagorean theorem. And the square root is there because you're isolating c instead of c squared. For both of these, you're doing each one of those things 4 times because you're going to have 4 sides. So if I'm checking slopes, I've got to do the slope formula 4 times. If I'm doing distance formula, I'm doing it 4 times. You don't necessarily have to get the decimal equivalents, guys. You can leave them as square roots. Just because you're just trying to verify that 2 numbers are exactly the same. So if it's like square root of 600, you can leave them as square root of 600. So as long as they both say the same thing, they're congruent. The last one you might use would be if you want to do a combination of it. In this last case, you would have to pick 1 pair of opposite sides, do distance formula for both of them, then do slope for both of them. So you're still doing 4 things. It's just giving you a mix and match of things to do here. All right. Now, chances are, if I asked you to show that something was a parallelogram, probably the easiest one to do is slope. Because if it's graphed out for you, you can just count your rise and run. Like the slope formula over there is if you don't want to graph it out. You're probably going to have graph paper available. It might be quick to just graph some points out and then just count rise and run. It's up to you. But slope formula is always going to be the quickest thing to use. Because there's places that people mess up on distance. So it's not usually the most efficient way to go about it. However, you can use it. But where you are going to have to use distance formula always is if they tell you this thing is a parallelogram and they want you to verify that the thing is a rhombus. Okay? Or prove whether or not something is a rhombus. Now, this isn't the only way. This is probably the easiest way. Okay? Other things would be like you would have to show that the 2 diagonals hit at the same midpoint because they bisect each other. Okay, so like I said on the previous slide, guys, since this one is telling you that they want you to be a parallelogram, what I would suggest doing, unless you really want to do distance formula, is just do the slopes of each side. Now, since this thing is graphed out, you don't even have to do slope formula. But since it is asking, like if you were just checking to see if it's parallelogram, you don't have to do it. However, if it asks you to say, or write like some kind of proof with this, then you are going to have to show that, use slope formula to show that the slopes are actually equal. Counting off rises and runs aren't going to count for some kind of proof. If the proof part wasn't there, then you could get away with that. Like if they just wanted you to say if this thing's a parallelogram or not, or identify what kind of shape it is. But in this case, it's not necessarily going to work out. Okay? All right, so what you need to do is first pair up your sides that are the opposite ones, such as looking at the picture, I can tell that EN and what's the other one? PI are the ones that are opposite each other. Okay, so my work, and this is going to be the actual work for the proof. Like I'm not writing out full sentences or anything here. What I'm doing is I'm checking the slope for that and the slope for that one. Okay. So my two y coordinates for E and for N should be, where's E? Right here. 3's for that one and 10's for that one. Right? I didn't screw that up. Correct? And then the two x coordinates are -6 and, 3? -3. Okay? Making sure that I have the same order there. Like here's point E, there's point N. So that's going to be -9, so 7 over 9. All right, so now again, for me to verify it, like I'm going to do the same thing for PI. As long as it gives me the exact same fraction, the thing is going to be a parallelogram, or at least the first half of this is. Because I know those sides will be parallel to each other. All right, so for P and I, I've got, what's that, 9 minus 2, and then 4 minus -5. Which is 7 over 9. So there I would say, look, say something like the slopes are equal, which makes PI parallel to EN. Okay, so in essence, what I did there, that's like the first half of the proof. The way I wrote it there is fine. Then I would move to the next pair of opposite sides. So I would look at the slope for PE and the slope for NI. Okay? So my two y coordinates for P and E should be 2 and 3. And the two x coordinates are -5, -6. So that means I got on top, I got -1. On the bottom, I've got, was that +1? So -1 is the slope there. So I do the same thing for N and I. So my two y coordinates are, 10 and 9. And 3 and 4. Which again, that's going to give me a +1 on top, -1 on the bottom, which is still -1. So again, slopes are equal there. Which means that those things are parallel. Which in turn means that the thing's a parallelogram. Okay, so that would be like the whole proof of it. All right, now again, I could have gone the alternate way. I could have done distance for each side and just show that the opposite sides have the same length. If you prefer that, do it. Generally speaking, the slope formula is a little bit easier to work with because you don't have to square numbers on top of subtracting them. All right, so this one doesn't have it graphed out. It would be a good idea to go ahead and graph it out just so that you can see where all the points are and make sure that you know which sides are the opposite sides, because again, I might have to verify which ones are opposite sides. I might not. Depends on what it's asking. Which one's this question asking? What do I want to show? Is it a parallelogram? Is that what they want me to ask? Okay, so if it's a rhombus. So here I don't necessarily care about which ones are the opposite sides, but I do want the order showing so that I know which 2 points create each side of the rhombus there. All right, so I've got 2, 2. So I got J's at 2, 2. Where's the other one? Next one at?
10, 0.
Wait, 0, 10?
And then 8, 8.
Wait, what's that one? P?
And then 8, 8.
P? No, M. Okay, so now again, drawing that out, the only real benefit to me having that there is so that I now know that those points U and M make a side, the points U and J make a side, J and P make a side, and M and P make a side. Okay? So again, for this to be the rhombus, I need all the sides to be the exact same length. Well, hold on. All right, so when I go through this, again, I'm doing distance formula here. So I'm subtracting the two x coordinates for each one of those points. So what is that, 8 and 0? Is that what you said? So 8 minus 0. It doesn't matter the order you subtract them as long as you subtract them. Because you're going to square it and the sign doesn't get affected there. What are the two y coordinates for U and M?
U is 0.
Wait, 8 and 10? Okay. So 8 minus 0 is 8. 8 minus 10 is negative 2. 8 squared is what?
64.
And negative 2 squared is? All right, so square root is 68. Okay, so that's like going to be my basis. As long as all the other ones, and to me being the square root of 68, I don't need the decimal equivalent. I just need them to look exactly the same. Then that thing is a rhombus. Okay, so now I go to U. From U to J. So I've got 2 and 0 being the x coordinates for those. And then I got 2 and 10 being the y coordinates. So 2 minus 0 is 2. 2 minus 10 is negative 8. So that's 4 plus 64, which again is square root of 68. So at least I know those two sides are congruent to each other. All right, then repeat the process again. So JP is 2 and 10 for my x coordinates, and 2 and 0 for my y coordinates, which that's negative 8. That's 2, so negative 8 squared is 64. 2 squared is 4, so again, square root is 68. Yes. All right, and then from M to P, I've got 8 and 10 for the x coordinates, and 8 and 0 for the y coordinates. So again, 8 minus 10 is negative 2. 8 minus 0 is 8, so I've got 4 plus 64, which is still, right? So then you can say something like, all sides are equal, therefore it is a rhombus. Okay, so I don't have to check the parallel stuff. That doesn't matter, because all you need for a rhombus is to have all the sides being congruent to each other. Next one we'll go through is 234. So this one's more general because they give you the coordinates. They don't tell you what type of quadrilateral it is. You have to graph it out and try and figure out which one it might be. It might just be just a random quadrilateral. It doesn't have to be any of the specific ones. Okay, and when I say specific, it means like square, rectangle, parallelogram, rhombus, trapezoid, or kite. What? You guys have a different one in there? Oh no, I put the graph in there. That's why you got the graph paper. I don't have graph paper up here. This is my graph paper. Okay, so like I said in the one with the rhombus, guys, if they give you the coordinates, it's a good idea to graph it out. One, because then you can tell, maybe give you a general idea what you think the shape is. Because if you can see what you think it might be, you could try and verify some properties to actually prove that it is a specific type of quadrilateral. Okay, so I've got...
It's a rectangle.
0, 0 for A.
0, 3 for
0, 3.
No. 3,
Oh, 0, 3, sorry. Not 3, 0. What's the other one?
5, 5.
5. 5?
5, 2.
5. So that's a rectangle?
Yeah.
No. No. What kind of angles do you have to have for a rectangle? Okay. Those are not right angles. Okay? So look, here's the thing. I know it's not a kite. I know it's not a trapezoid. Right? I can throw those out just by looking at it. And it's not going to be a rectangle or square because I don't have right angles. So it's either a parallelogram or a rhombus. But this side and this side are definitely not the same length. So no, it's not a rhombus. So my guess would be that it's a parallelogram. Okay, now, again, since it says prove your answer, that means I can't just go with, well, it looks like it. You just got to show that they're parallel to each other. Okay? Mean that you have to check the slopes of each one. Like the slope for this line, like I'll just do rise over run for this one, right? We'll just check those out. The slope for AB is a rise that is what, 3? And a run that's 0. So undefined. All right, we know it's a straight vertical line. So if I look at the one that's opposite it, same thing, correct? It goes up 3 over 0, boom. So I know since those slopes are the same, then I can say AB is parallel to CD. Then I can do the same thing for the other lines. Okay, so for this one up here, right, I got a slope that is up 2, and then over how far? How far does it go horizontally to get to here? 5. What about down here? It's up how many? Up 2, 5. That's your whole justification. So if one of those was off by a little bit, like if for some reason they stretched it just a little tiny bit longer and you don't have them parallel, you would just say it's a regular old quadrilateral. Nothing special about it. Okay, but since you got the sides being parallel, that's enough to show it. Do this one next. All right, this isn't in the book. These last two are not in the book, guys. You're going to have to write the problems out and then use the graph paper if you want to do the graph paper. Okay? It's not necessary to graph this one out. As long as you know which sides are the bases and you can figure out what maybe the height is, you don't necessarily have to graph it. However, it's probably going to be beneficial to graph it than not. A is negative 3, 0, correct up there? Yes? What's the next point? Someone get to me. What's B? Is there a B?
Negative 3,
4.
4. 2, 4.
Wait, 2, 4 is what? C?
Yeah. 4, 0 is D. 4 over 0.
Okay. All right, so they already told me it's a trapezoid, but I could look at it and tell because I have those two sides being parallel, which means that that's base 1, that's base 2. Which again matters because remember the area formula?
Half of base 1 is base 2.
Times the height. Okay, and remember the height is the vertical distance or straight distance from one base to the other. Now the points here were nice and neat because they made this a vertical line between them, which means that this has to be the height because it makes right angles with the bases. Okay? If they didn't have that in there, you would just have to draw the height in there, and you could probably just count it as long as the bases are horizontal. All right? If they give it to you at some kind of angle, like if I had this turned, you would have to do distance formula for this number, and that number. But it just worked out to be nice and neat here. So this is, how far does that go vertically? 4. Okay. Okay, since this is horizontal, I can just count. So this length of this base is 1, 2, 5. What's the length of this one? 7. Okay, so my area should be 1/2, 7. And what's 5 plus 7?
So 6 times 4 is 24.
With the question here, they're giving you 3 of the vertices for a parallelogram. And they give you options there for another point that could complete the parallelogram. And it's saying that 3 of those should work. One of them's not going to work. All right, so we'll start with plotting out the points. So, I don't know what we'll call there's 6, 4. So there's 1 point. Another one is 8, 1. And 2, 0. There. Okay? So now here's the thing. If I connect these, there's a few ways you can connect them. I can say that's 2 sides of it, which means that the 4th vertex would be somewhere over here. All right? I could connect them this way, which means my other vertex is over here. Or I could connect it that way, which puts it down there. All right? Now, the way you identify where the other vertex should be, let's say if I did it with those points right there. Like if I had it drawn that way. I know that if I did another point, let's say I started this one, it's got to be parallel to this line here. Now, to go from, we'll say this is point A and B. To go from A and B, you have to go down 3 and then over 2 to the right. So if I were to start here and make another point that has the same slope, I would go down 3, over 2.
4, -3.
That point right there, 4, -3, would create a parallelogram because I know that these 2 sides are going to be parallel to each other. All right, and in turn, so is that. So is that one of the answers up there?
Yeah.
So cross it off, right? Because we're trying to find the one that doesn't work. All right, so now,
0, 3, 1.
so now again, well, I'm going to go through the whole process here. So if I did the same thing here, so again, if I go from B to A, that's over 2 and up 3. So here, if I go over 2 and up 3, 0, 3, that would also create a parallelogram. So if that's up there, cross that off. And then my other option would be here. So for this one here, I have to go, 6 over and up 1. So if I start here and go 6 over, 1, 2, 3, 4, 5, 6, then up 1, that would put me there, which is 12, 5. Okay? So if I cross all those off, so those are all my options there. And the matter of finding that third is just doing some rise over run to count to the next point. The only one left with would be 6, -2, which even if I graphed it, let's see. Like if you just went through graphing points, 6, -2 would be like right here. So if I kind of drew those out, you could kind of see it's not a parallelogram anyway. Okay? So you got a few options here. You can either count off, you can plot all the points and connect the sides and see what it is, but it's going to take a lot of erasing on problems like this. Which these come up on FSAs, okay? All right, so your guys' stuff tonight, you got to go to the website, guys, get the worksheet that's on there.